What if the Earth, our colossal blue marble, suddenly stopped spinning for just 1 second? It sounds like a brief pause, a tiny glitch in the cosmos, but the reality would be a cataclysm of unimaginable proportions. Let's explore this mind-bending scenario together. Right now, as you're watching this, you, me, and everything on the planet's surface are hurtling eastward at incredible speeds. At the equator, we're moving at over 1,000 miles per hour, or about 1,670 kilometers per hour. We don't feel it because everything around us, the atmosphere, the oceans, the ground beneath our feet, is moving along with us. It's like being in a car on the highway. You don't feel the speed until someone slams on the brakes. And that's exactly what would happen. The Earth stopped spinning, the ground would halt, but our inertia, our tendency to keep moving would not. Everything not securely anchored to the planet's bedrock would be flung eastward at that immense speed. Imagine it. People, cars, trees, animals, and even the topsoil would become projectiles launched across the landscape at supersonic speeds. 1 second of stillness and everything changes. The force would be so extreme that it would instantly pulverize anything in its path. No building, no matter how well constructed, could withstand such a force. Cities would be flattened in an instant, reduced to rubble. But the devastation wouldn't stop there. Think about the oceans. They hold an enormous amount of kinetic energy. A sudden stop would cause colossal tsunamis, unlike anything ever recorded. The water would continue its eastward motion, surging over the continents in a gigantic, world-engulfing wave. We're talking about oceans, flooding continents, washing over mountains, and reshaping the very face of the Earth. Coastal regions would vanish in the blink of an eye, and inland areas would be scoured clean by the rushing water. And what about the atmosphere? The air, just like us, is also moving with the Earth's rotation. If the planet stopped, the atmosphere would keep going, creating the most powerful winds in history. Winds would reach over 1,000 miles per hour, far exceeding the strength of the most violent hurricane ever recorded. These winds would generate so much friction against the Earth's surface that they would likely ignite global firestorms, stripping away whatever wasn't already destroyed by the initial impact and the subsequent tsunamis. Even the planet itself would suffer. The immense stress on the Earth's crust from such an abrupt halt could trigger unprecedented earthquakes and volcanic eruptions all over the globe. The planet's molten core would continue to spin, creating a massive shearing force between the core and the mantle, tearing the planet apart from the inside. And after that single, catastrophic second, if the Earth were to resume its spin, the chaos would simply reverse. The oceans would slosh back, creating another wave of destruction. The winds might reverse direction. The whiplash effect would be just as devastating as the initial stop. But what if it just stopped and stayed stopped? The side of the Earth facing the sun would be locked in perpetual daylight, baking under its constant, relentless heat until it became an uninhabitable desert. Temperatures would soar, boiling away any remaining water. Meanwhile, the dark side would be plunged into an eternal, freezing night. Temperatures would plummet to levels that would freeze nitrogen out of the atmosphere. A thin, habitable zone might exist in the twilight region between the two extremes. But the conditions would be incredibly harsh. A day would last a full year, with 6 months of scorching sun, followed by 6 months of frigid darkness. This thought experiment is a powerful reminder of the delicate and dynamic balance that makes life on Earth possible. Our planet's constant, steady rotation is not just a background feature of our world. It's the very engine that drives the stable climate, the tides, and the day-night cycle that all life has adapted to. A single second of interruption would unleash a chain reaction of destruction that would erase civilization and likely all complex life from the planet. Thankfully, the laws of physics ensure this won't happen. The Earth's rotational momentum is immense, and there's no known force capable of stopping it so abruptly. But exploring these what-if scenarios helps us appreciate the intricate and beautiful cosmic dance we are a part of every single day. Thank you so much for joining me on this wild journey through physics and imagination. If you enjoyed this and want to explore more mind-blowing scenarios, make sure to hit that like button and subscribe to the channel. Let me know in the comments what other cosmic what-ifs you'd like to see next. See you in the next video. Look up at the sky. See that brilliant, glowing star. That's our sun. For billions of years, it's been the source of all life on Earth. It warms our planet, fuels our ecosystems, and marks the passage of our days. It's the silent, constant force that has allowed humanity to rise, to build cities, to write poetry, and to dream of the cosmos. We are, in every sense of the word, children of the sun. But the universe operates on timelines far grander and more indifferent than our own. And like all stars, our sun has a life cycle. It was born, it is living, and one day it will die. This isn't science fiction. It's a cosmic certainty. The very star that gives us life will, one day, be the force that ends it all. Let's travel forward in time, about 5 billion years from now. Our sun is running low on its primary fuel, hydrogen. Deep within its core, the delicate balance between gravity pulling inward and nuclear fusion pushing outward begins to fail. Gravity starts to win, compressing the core and causing it to heat up to unimaginable temperatures. This intense heat ignites a new phase of fusion, burning helium into heavier elements. The outer layers of the sun, supercharged by this new, ferocious energy, will swell dramatically. Our familiar yellow star will begin to expand, transforming into what astronomers call a red giant. It will grow larger and larger and larger still, so large that it will engulf the inner planets. Mercury, then Venus, will be vaporized, becoming nothing more than wisps of gas in the sun's expanding atmosphere. And then it will come for Earth. The sky, once blue, will be filled entirely by a blood-red, blistering inferno. The oceans, where life first began, will boil away into steam. The continents will crack and melt. The very ground beneath our feet will turn to lava. Every monument we've ever built, every story we've ever told, every trace of our existence will be erased in a final, fiery apocalypse. Our world, our beautiful blue marble, will be consumed. After this cataclysmic expansion, the sun's outer layers will drift away, creating a spectacular, glowing nebula ghostly memorial to a star that once nurtured a solar system. At the center, all that will remain is the sun's dead core, a white dwarf, a super-dense Earth-sized ember, slowly cooling in the silent darkness of space. It will no longer provide light or warmth, just a faint glow in the eternal night. Does this thought make you feel small? It should. It's a humbling reminder that our time here is incredibly precious and fleeting in the grand cosmic play. But it's not a reason for despair. It's a reason for wonder. It's a call to appreciate the here and now, this perfect, cut-bay moment where a star and a planet are in perfect harmony to support us. We are living in the golden age of our solar system. We have the unique privilege of looking up at the stars and understanding our place among them. So, cherish the sunlight on your face. Cherish the warmth of our star, because we are part of a magnificent, unfolding story of life, death, and cosmic rebirth. Thank you for joining me on this journey through time. If you found this perspective as awe-inspiring as I do, consider subscribing and hitting that notification bell for more explorations into the cosmos. Stay curious. Have you ever looked up at the night sky and wondered if the universe is expanding? What is it expanding into? What lies beyond its edge? It's a question that has baffled scientists and philosophers for centuries. Let's start with what we know. The universe is big, unimaginably big, and it's getting bigger every second. This expansion started about 13.8 billion years ago with the Big Bang. But it's not like an explosion in space. Instead, it's space itself that is stretching. Think of a loaf of raisin bread rising in the oven. The raisins aren't moving asterisk through asterisk the dough. The dough itself expands, carrying the raisins further apart. In this analogy, galaxies are the raisins and space-time is the dough. So, when we look out into the cosmos, the light from the most distant galaxies has traveled for billions of years to reach us. This creates what we call the observable universe. It's a sphere with us at the center, and its edge is the farthest we can possibly see. This boundary is called the cosmic horizon. It's not a physical wall, but a limit set by the speed of light and the age of the universe. Light from anything beyond this horizon simply hasn't had enough time to reach us yet. This leads us to the big question: what's beyond that horizon? Is it just more of the same? More galaxies, more stars, more planets, stretching on infinitely. This is one of the most popular theories. In an infinite universe, there is no edge. The concept of beyond simply doesn't apply, because there's always more universe. It's a mind-bending idea, but it's consistent with our current understanding of cosmology. The universe appears to be flat on the largest scales, which mathematically suggests it could go on forever. But what if it's not infinite? Another idea is the multiverse. Our universe could be just one bubble in a vast cosmic foam of other universes. Each of these bubbles could have its own unique set of physical laws. In one, gravity might be weaker. In another, there might be different fundamental particles. In this scenario, beyond our universe would be other universes. The space between them would be a strange, chaotic void where the very concept of physics as we know it breaks down. Imagine trying to cross an ocean between continents, but the ocean itself is made of something completely alien to our reality. Then there are more abstract theories. Some physicists speculate that our universe might be a 3D hologram projected from a 2D surface at its boundary. It sounds like science fiction, but it's a serious attempt to reconcile quantum mechanics and general relativity. If this is true, then the question of what's beyond becomes even weirder. It might be a lower dimensional reality that contains all the information of our own. Ultimately, we don't have a definitive answer. We are limited by our cosmic horizon. We can create powerful mathematical models and theories, but we can't send a probe to go and look. The space beyond the observable universe is expanding away from us faster than the speed of light, making it forever unreachable. So, the edge of the universe might not be a place, but a limit to our knowledge. A frontier where our physics breaks down and imagination takes over. It's a profound reminder that as much as we've discovered, the cosmos still holds secrets that are perhaps forever beyond our grasp. The quest to understand it is what drives science forward, pushing the boundaries of what we know, one galaxy at a time. What do you think lies beyond the edge? Let me know your theories in the comments below. Thanks for joining me on this cosmic journey. If you enjoyed this, don't forget to like, subscribe, and hit the bell icon so you don't miss our next exploration into the great unknown. What if you jumped into a black hole? It's a question that tickles the very edge of human imagination, a one-way trip into the ultimate unknown. Let's embark on this journey together, not with a spaceship, but with the power of physics and a little bit of cosmic curiosity. Imagine you're an astronaut, floating in the silent, star-dusted expanse of space. Before you looms a region of pure blackness, a circle of nothing that seems to devour the light of the stars behind it. This is the event horizon, the point of no return. You take a deep breath, and you jump. As you drift closer, the first thing you'd notice is something truly bizarre happening to the universe around you. The light from distant stars begins to bend and warp, creating a beautiful, distorted halo around the black hole's edge. This isn't an illusion. It's gravity, so immense that it's literally bending the fabric of space-time itself. The view would be spectacular. A cosmic funhouse mirror showing you the entire history of the universe in a flash. But your own experience of time would be just as strange. To a friend watching from a safe distance, you would appear to slow down, getting redder and dimmer as you approach the event horizon, eventually freezing in place for what seems like an eternity. But for you, time would feel normal. In fact, you'd watch the entire future of the universe flash before your eyes in what feels like mere moments. Billions, even trillions of years would pass in the outside world while you simply fall. As you cross the event horizon, there's no dramatic explosion or sudden jolt. You just float through, seamlessly. The laws of physics as we know them haven't broken yet, but you have sealed your fate. There is no going back. From this point on, all paths lead to one place, the center. Now, things get a bit uncomfortable. The immense gravity of the black hole starts to pull on your body unevenly. Let's say you're falling feet first. The gravitational pull on your feet would be exponentially stronger than the pull on your head. This tidal force would begin to stretch you, gently at first, then with unimaginable power. This process has a rather vivid, if unsettling, name: spaghettification. Your body would be elongated, pulled into a thin stream of atoms, like a piece of spaghetti being stretched until it snaps. It's a grim thought, but it's the stark reality of physics at its most extreme. You wouldn't be you anymore, but a river of fundamental particles flowing toward the heart of the abyss. And what lies at that heart? A singularity. This is the point where our understanding of the universe completely breaks down. It's a point of infinite density and zero volume, where space-time curvature becomes infinite. What happens here? Does it lead to another universe? Is it the end of everything? We simply don't know. The laws of physics that have guided us so well from quantum mechanics to general relativity cry out in unison that they can no longer provide an answer. Your journey, which began with a single leap, ends here. Your matter, the very atoms that once made up your body, your memories, and your dreams, would be crushed into this infinitesimal point, becoming one with the black hole itself. You wouldn't just be asterisk and asterisk the black hole. You would asterisk become asterisk part of it. Part of its mass, part of its gravity, part of its mystery. You become part of infinity. So, while we can't actually take this trip, thinking about it pushes the boundaries of our knowledge and fuels our desire to understand the cosmos. It reminds us that we live in a universe filled with wonders that are stranger and more magnificent than we can possibly imagine. Thank you so much for joining me on this cosmic adventure. If you enjoyed this journey into the unknown, please hit that like button and consider subscribing for more deep dives into the mysteries of our universe. Stay curious and keep looking up.